break problem number 3 into 2 separate triangles and then use the SAS area conjecture on both of those. We aren't going to break the triangles this way, because if I look at this triangle, I would know a side length and a side length, but I would not know the angle in between. I would not have enough information to use the SAS area conjecture. So we have to break the triangles this way. So this triangle, its area can be found with 1/2 the 2 side lengths multiplied together, multiplied by the sine of the angle between them. This triangle is also 1/2 the 2 side lengths multiplied by the sine of the angle between. Find the answers and then add them together. Do not round your answer until you have found both areas. So your very last step should be rounding, not before. To find the area of the trapezoid in problem 3 from RT4, lesson 2, we're going to break this into a couple of different polygons. So if I drop 2 altitudes here, I've now created an 8 by something rectangle, and the area of that will be the base times the height, whatever we find that height to be. And then I've got 2 triangles, which I will use 1/2 base times height. I know the base of this triangle. These 2 will be the same. This is an isosceles trapezoid. I'm not quite sure how I know that, but I do. And I know that this will be congruent to that. So I'll take my 8 feet, I'll subtract off 14 minus 8, and I'll end up with 6. So I know each of these is 3. So I'm going to say that the base is 3, and now we're going to need to find h. To find h, I can use the sine of 55 degrees is equal to h over 5. So I'll multiply this by 5 to clear that denominator. I can now use this number in both of my formulas. I can erase the h in the parallelogram formula and replace it with 5 times the sine of 55. And I can erase h in the triangle formula and replace it with 5 times the sine of 55. Find the answer to both of those, add them up, and then round, but do not round until the very last step.